Hi guys, welcome back to the channel. This is Robin Williams with another challenge lab for you. Okay, today we've got a fairly straightforward and simple OSPF lab. As you can see, we've got a topology of 4 devices here: Plato, Socrates, Aristotle and Epicurus. What we're going to do is we're going to configure OSPF connectivity between all the routers interfaces. I've mentioned physical interfaces, but there is also a loopback in Aristotle, which we're going to include, and then we're going to do something with that loopback afterwards. We're going to set the router ID of Socrates to 2222 and check the other devices see the correct router ID when they check for their neighbor table. We're going to force Socrates here to become the DR on both its segments. So that will be the segments between Socrates and Plato, and also the segment between Socrates and Aristotle. We're then going to create the loopback on Aristotle with the address of 4444 and a /24. We're going to advertise this into OSPF, and we're going to ensure that the routing tables of the other routers in the topology show the correct subnet mask and not a /32. And then finally, we're going to do a little bit of traffic engineering so that pings from Plato to the loopback of Aristotle will only pass via Socrates and they will not pass via Epicurus. So, without any further delay, let's get into these devices. So, start off on Plato, I think, into configuration mode. Oop, having a bit of a fat finger moment here by the looks of it. Okay, so this command here, the network 000000, the 4 zeros followed by 4 zeros again, that basically just enables OSPF on every interface on the router. It can be handy when you've got more than 1 or 2 interfaces to configure. Just bear in mind that obviously that enables it on every single interface. If there's an interface that you don't want to participate in, don't use that command. It would be the best piece of advice, really. So Plato's done. Let's move on to the next device. Let's go over and do Socrates. Okay. A couple of things to speak about. Configuring OSPF and the difference between an EIGRP. First off, the autonomous system number does not need to match in OSPF. In EIGRP, it does need to match, otherwise a neighbour relationship won't form, but in OSPF an adjacency will still form if you're using different AS numbers. The other thing to note, of course, is that we have to place the area command in. So basically you're telling the interface which area which OSPF area, that you want the interface to be in as well. So they're just two things to look out for. So that's Socrates done. Let's move on to Aristotle and Epicurus. Just to show you the AS difference here, that you can have different AS numbers and it will still form a neighbour relationship. So there we go. I've just basically gone network, basically put all your interfaces into area 0. And lastly, I believe it's Aristotle we've got to do. Okay, as you can see, I've already created the loopback address. I am going to put the 40 command in again. The 8 zeros, you should say, I suppose. That will advertise OSPF now, advertise the loopback now. There's just something else I wanted to show you on there. So as you can see here, this is, I believe, the only device with OSPF 100 as the AS, and it's already started to form an adjacency there. So let's just have a little look across all our devices and check what we've got now. check that with your show IP OSPF neighbour command, and as you can see, we've got a neighbour relationship formed between Plato and Aristotle. A little bit interesting to note, we're going to talk about the router ID next. Now, as you can see, the neighbour Aristotle has announced itself as 4444, and the neighbour Plato has announced itself as 192.168.30.1. Okay, the reason behind that is OSPF has a process for choosing its router ID. First off, if you explicitly configure a router ID, which we're going to do in a moment, it will take that. Secondly, it looks for the highest loopback address, and it will use that as the router ID. Thirdly, if neither of those are configured, it will look for the highest physical interface on the router and announce that. So even though the link between Plato and Socrates is across the 10 interface, or the 10 network, it still gets announced in the ID as 30.1 because that's the highest numbered interface on Plato. So we're now going to play with the router ID, and we're just going to force Socrates to announce itself as 2222. So if you were to look at Plato, this is one of his neighbours. Let's just have a look and see what he sees as his neighbours at the moment. So he sees 30.3, which is Epicurus, and he also sees 40.2, which is Socrates, and you can actually see it knows it via the address of 10.2, which is the interface here. Okay, what we're going to do in Socrates, we're going to go into the, I believe it's OSPF 1, yeah, okay, we're going to go into the routing process, okay. And let's have a little look what we've got as our okay. So what did we have as our options there? Let's have a quick look. Okay, so basically we're going to choose router ID, okay. Router ID, and then you can name it. Okay, you can see here it tells you to reload or use the clear IP OSPF process command for this to take effect. So if we were to look on the neighbour now, on say for instance Plato as his neighbour, we won't see any change in what the neighbours are called. Okay, so let's clear it from Socrates. Always asks you to, if you want to do that as a confirmation, because obviously what this does, it tears down any OSPF relationships that you've got. Not something you want to do in the middle of a day on a production network. So we can see that the neighbour relationship between Socrates and Plato has broken, but let's just and reformed. So let's just have a quick look and see whether that's changed. Okay, so at the moment you can see it's in this X start state here. Okay, so we're just going to have a little look and see if that clears. Took a little bit of time to do there, and as you can see, you now have 2.2.2 being announced as the neighbour instead of 40.2. So we can see that the correct router ID is now being advertised out via Socrates. Let's just have a quick look on his other neighbour, which is Aristotle. And again, you can see that the neighbour is now being announced as 2.2.2. So that's the first two challenges done. Next thing we want to do is we want to force Socrates to become the DR on both its segments. So if we look at Plato, for instance, you can see that Socrates, which is now 2.2.2, is the BDR. Okay. If we have a look on Aristotle, you can see that 2.2.2 is also the BDR. So how do we go about changing that? How do we force Socrates to be the DR? Well, the answer is that we need to raise the priority on Socrates. So let's have a little look at what we're going to do. Okay, so we're going to Socrates. And we have to do this in the interface configuration mode. We use the command IP, OSPF, the process ID, which in our case is 1. Or rather than that, if we can just go straight into the priority command, sorry. And we're just going to raise that to 100. Okay. And then we're going to do the same on the link to its other neighbour as well. Okay, so that sets the IP priority to 100. What we then need to do, okay, is again, we need to clear the IP, the routing process on both sides. So we're going to reset the process on Socrates. We're now going to reset the process on Plato and Aristotle as well. Oh, fat fingers this morning. Okay. And you'll always be asked to confirm that you want to do this, because obviously it's quite a destructive okay, yeah, it'll always ask you to do that because it tears down the relationship, and obviously that can be quite destructive during a working day. Okay, so we can see very, very quickly that the neighbour relationships have come back up. So if we go back to, okay, you can now see that 2222 has become the DR, or in other words, Socrates has become the DR. Okay, just check that by showing IP. Well, you can see there that it's 10.2. You can see the neighbour ID. You can see it's known via 10.2, and you can see it's now become the DR. So that's on Plato. And if we just go and have a quick look at Aristotle to confirm that Aristotle also sees the same thing, I'm going to show IP OSPF neighbour command. And again, here you can see 2.2.2 has now become the DR. You can also see the priority status there. And you can see the interface that it's known about on there as well. So that's the forcing Socrates to become the DR on both its segments. So the next thing that we've asked you to do is Aristotle has got a loopback address. I've already created the loopback address just to save some time. I'll just show you the devices now. Okay, so here we have this loopback address 4444. Now that is set. I'll show you the, so you can see that it's set as a /24. It's 444 and then just a straight 3255, so make it a /24. Now the interesting thing with loopback addresses is if I look on any other device, say on Plato, and I do a show IP route, you can see that 4.4.4, or the 4 network I should say, to mention itself as a /32. Why is that? That's just the way that OSPF works. OSPF by default does not advertises the subnet subnet mask of loopbacks as a host route. So it'll always announce them as a /32. If you want to change them so it's got the correct net mask in there, you must go to the device itself on Aristotle. Okay. And in the loopback configuration itself, you must change the loopback network type. So it's IP OSPF network .2 point. Okay. Now if we go across to any other device, go back to Plato, you'll see now that the 4 network is being advertised correctly with a /24. Okay, so the final challenge we now have is we've got to do a little bit of traffic engineering. So we're going to ensure that traffic from Plato here, when it goes to that 4.4 network on Aristotle, we want it to take a particular path. What we want to do is we want to force it across this way through via Socrates. We don't want it to go via Epicurus. So if you were to look at Plato now and look at its routing table again, you can see at the moment to reach the 4.4 network it has a choice of 2 paths. It can either go via 30.3, which is via Epicurus, or it can go via 10.2, which is via Socrates, which is what we want. Also, if I trace to that address, you can see how it's load balancing between the two. If you have equal cost paths in OSPF, the routing protocol will load balance on there. So how do we change that then? It's not too difficult at all. Okay. What you do is you've got to think about how OSPF works with its metrics. Basically, OSPF works its metrics out by path cost, and this is based on the cost on the outgoing interface from the router's perspective across the path. So any outgoing interface across the path that's going to the destination, okay, that is what counts towards the cost from the perspective of the outgoing router. So what we're going to do in this case is we're going to go to this interface here, okay, and we're going to just basically increase the cost. So you go, okay, what that will do, that will now make this path far less attractive to OSPF, and it will force all the traffic through here. So if we now take a look, you can see that to reach the 4 network we only have the 1 path, and I can also prove that to you now. As you can see, it's now only taking path between 2 and then 4. Okay, so that's everything that you need to know for the basic OSPF lab. If you've got any questions, please leave them in the comments below. Don't forget to hit subscribe, as I'll be putting up some more videos for you later on. And enjoy yourselves, enjoy with GNS3. Cheers guys, bye bye.